Check. Fine. So today we're going to again dive into the wonderful idea of functions. Function. So we do plan a function, Akriti. Like suppose we plan a function like let us say happy birthday. We are going to celebrate the happy birthday. So what all we do? We plan how many guests are going to come. We plan how many ingredients we are going to serve them. Like suppose we are going to serve them pizza, French fries, rasgulla, different kind of things. So in all these functions, there is one thing that you have got an input, and then after doing the function, let us say, then there is a output, which I say that everybody is happy after the function. Okay, but there is a thing that if there are, let us say, different inputs, let us say there are different inputs, so for each input one thing is for sure. So it may happen that suppose you think that you organized a function and there are two kinds of things that are coming out of your house. Let us say you planned a movie, you went to the movie, so there will be a different opinion of a person. Somebody will say it is a good movie, they are happy. Somebody will say none of them acts good, so everybody is unhappy. So we have got different values. So these values which are coming as an output in a graph is known as y. It is represented on y-axis. And all of you who went to see the movie are known as x values. You are represented a graph on as x values. So when a graph is said to be a function, a graph is said to be a function if for each value of x you get a unique value of y. You write down this. A graph is said to be a function. A graph is said to be a function if for one single value of x, if for unique value of x, you get one and only one unique value of y. If the ingredients are same, like suppose you think that two hotels, two restaurants of different area but having the same ingredients, same cooking time, same ingredients are being there, what do you think? What is the outcome? It will be same only. It will not be like suppose you are putting a paneer and the result is coming out as rajma. Sometimes it is coming as rajma, sometimes the paneer is converted into curd. Will it happen? No. If the input is same, the output is also same. It may happen that two of the different methods can make you land up to the same thing. So it can happen for two different x, you get the same y. But it should not be there for the single x, you get two different y. Two different results are not allowed. Two different results are not allowed. So how many functions, kinds of functions we all know? So one of the function, let us say, is a polynomial function. Then we have a trigonometric function. Then we have exponential function. Then we have logarithmic function. And so on. There are different kind of functions. And in a polynomial function, if you look at it, if the power is 1, let us say y is equal to mx plus c, this is known as linear function, which you recently learned from me, where c is the y-intercept, m is the slope of the graph. Then there is one more kind of function which is known as quadratic function. So y is equal to ax square plus bx plus c. This is a quadratic. Can I take a call, dear?
Yes.
Hello. Okay. So this is known as quadratic function. Then you can have one more, y is equal to ax cube plus bx square plus cx plus d. This may be known as cubic function. So we are going around these two ideas only, linear and quadratic. In your syllabus, we will stuck about making the graph of linear and quadratic. Then there is a modulus function as well. Then there is greatest integer function. Then there is sinum function. These are the different functions that we deal with. Going next year in the calculus, we will see all these functions. Done?
Yes.
Let us say if we are able to just check the functions or not. So for that, I will just take you to the IXL. Please log in your ID. So function concepts. So there are two things that you must know. First is the domain and second is the range. Just confirm me, dear. Have you done this sheet earlier? I want to just check. In pre-calculus, it is the first sheet, domain and range. It talks about domain and range.
Yes.
You have done
I
it
did up
already?
to 3. 83. I've done up to 83.
83. So start now. Let us complete this.
No. I've done up to 83. I've done domain, range, identity function, and evaluate function.
Wonderful. So we will go with the A4 sheet. Now we have to find the value of the graph. So we have to see if we are able to look at the graph or not. So suppose somebody asks you, what is G6? You will say G6. Okay, so you will go to 6. You will check what point it is. You say it is 6. So it is how much? 6. That's so easy. Start. Finish it. I suppose that you can finish this sheet in just 2 minutes. Quickly. Start doing A4. You have to watch the graph and you have to fill the values. That's it.
Wait, so
You can share your screen as well. Okay, good one. So this is a graph in front of you. So you need to find, okay, so no. First you have to move to 6, my dear. See, Gx is equal to 6. It is not x is equal to 6. They are not asking you to find G6. Yeah, so when Gx is equal to 6, what is the value of x? Tell me. 3. Wonderful. Wonderful. So it is 3. So what is the value at which fx is equal to 8? So there are two values for which fx is equal to 8, and these, why we are having two values? Because this is a quadratic function. This has got polynomial function. Quadratic. 2 zeros, 2 values. Wonderful, well done. Moving on to the next question. So use this graph to find f2. So you have to reach to f2. Okay, no. How much you got? F2 as F2 is dear, this is F2. You were looking at this. So F2 is 10.
Oh, not F. Huh? Wait.
See, f of 2 means function at 2.
Mhm.
So what is that? If you go up, it is 10.
Okay.
You wrote 0?
No, I wrote 6.
Okay. Can you tell me what is at what value of x you need fx is equal to 4?
Is it 3?
So first go to
Yeah.
4. Yeah, you have got two values. So 3 and 9. Wonderful. So use this graph of G to find G5. So you have to go G5 is 0, I think.
0.
Yes. Fx is equal to 10. So f of x is equal to 10. So at what? So first you have to reach 10, my dear, and then the value is 8. Yes. Now just finish it. Do it yourself. I am not going to guide you anything. I will watch. Very good. Well done. Great job. So you will see when there is a straight line, you have got single solution. When there is not a straight line, it is a curved graph, you get more than one solution.
Mhm.
But x you are getting one only. So fx is equal to 3.
Yeah, because there's no.
0. No, 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 no.
But then if it's intersecting here, then wouldn't it be 3?
But are they asking you what is y? They are asking you x.
It makes 0.
Yes. You have to see through the graph what they are asking you. So if they are asking you f1, you go to 1, yeah, and then check the graph. Where is the graph touching 3? So f1 is 3. Now they are saying that f of x is minus 5. So you go to minus 5 first. Yes. So what is the value when x is minus 5? No, no, no. There is not happening. You go to the graph, go to the right side, extreme right. No, no, no. That is not the. You have to see where the graph is having minus 5 value. Yes.
10.
So the value is 10. Understood now?
Yes. Oh, it's an M.
Okay. So you've been asked f of 5. So you have to reach at 5. Yeah, x at 5. Then see where it is touching the graph.
4.
4. So f of 5 is 4. Great going, beta.
Minus.
So at, yeah, wonderful.
7.
7, correct. So f of minus 3. So you have to reach to x equal to minus 3. No, first reach x equal to minus 3. See, the value of x you have to go to minus 3. Yes. And then go to the graph, where the graph is touching, where the line is intersecting the graph at minus 3. Wonderful. Minus 6. So f of minus 3 is minus 6. Good one. Use this graph f to find the value of fx equal to 0.
Minus 4 and 5.
No, no, no. How much?
Minus 4 and 5.
Correct. Well done. Excellent. Use this graph f to find f of 6.
4.
F of 6 is 4. f of 4 is 6. Yes, 6. You can't have two values in a function, so it's a single value. So f of minus 1. So tell me, what is f of minus 1? First go to minus 1, x equal to minus 1. See what is the value? 0.
Is it -2 or 0?
0, my dear, where the graph is having a darkened one.
Okay.
Very good. You got 3 values. Wonderful. So for a single x, you can find that there are 3 different values. No.
Yeah.
For a single
Right?
y,
No, for a single.
for a single y,
x.
you can have 3 different x.
Yeah.
But for a single x, you can't have 3 different y. That will not be a function. G of x is equal to 5. At what value of x you are getting 5? Yes, the graph is touching at 2 different points.
3.
Okay, good one. Is it 3 really?
Yeah.
Okay. No, yeah, 3 different points. Okay, fine. I thought that 3 is the answer. Okay. Good one. See how much time you took? 9 minutes 26 seconds for 24 questions. Very well done, beta. Moving on to the next sheet. We will go serially because it helps to align with the curriculum. So complete the table for the function graph. So now this time, have you done A4 recently, I think? Yes.
A4 we just finished.
Yes. So we have to do A5 now. So complete the table for a function graph. So you have a function. Can you first tell me what kind of function is this for you?
To your screen.
Okay, my screen is, you can see it is a linear function. For you, it is a quadratic function.
Quadratic.
So for 3 also you are getting 5, for 7 also you are getting 5, but when you see f of 5, so you will get the maximum value, that is 7. That is 7. Good one. So now you can just keep doing all this. It's very easy sheet.
Yes.
So you have to find f of 3 is 6. Okay, you are on the next question. 4. Okay. Great speed. So at 2 the value is -1.
It's all -1.
Yes, but yeah, -1 only. So at -7, so you go to -7, the value is -3. Yes, at -6, the value is again -3. Good. So you can see for 3 different values of x, you can get a single y. The y is same. So that can happen, that using 3 different ways you can build a paneer. But it is not like if the ingredient is same.
Yes.
So x equal to 6. So you are also doing yours, then I will do mine. Okay, let us see who
Yes.
completes the first. So you got 75 marks. So 6, x equal to 6, the value is going to be 7. Now we have to complete this graph. At 7 it is 0.
Oh no, I was so close. I got to 69. I didn't see, because this is very oh, it's 9. Oops. Okay.
Okay, so if you, okay, so if I'm looking at this graph, at 5 the value is going to be -2. Then at 7 the graph, we will look at it, the value is 2. You came to 68.
Yeah, I don't know why he keeps doing that. I got one wrong. Oof.
See, I reached to 47. Okay, next question is to complete the table. So g of x for -7, you go to the -7 and then see the graph is touching at 6. So we will write 6. Again at x equal to -4, the graph is touching at 7. So this is 7. So at x equal to 1, if I look, the graph is going to be 0. At x equal to 4, the graph is going to be -7. So 0 the value is 1. For 2 the value is -2.
Wait, sir, for this question, there's 2 values. So do we take the filled out one or the
Filled out one, my dear, filled out one. The other one is approaching value, it is the limit. You will learn that in limit. Good one. So -4 the value is 2. For 0 the value is again 2 only. So -5 the value is 5. For 10 the value is 7. -10 the value is 4. -1 the value is 2. For minus 10 the value is negative 8. For 9 the value is 2. So you are on 99, I am on 83. So you have to be very careful in doing this.
Yes.
So well done.
I did it.
So Akriti has completed all the 15 more questions you did,
Yes.
and in just doing 21 questions you finished this 100. Good one. Okay, now let's move on to the next series of questions, that is A6. So in this we have to identify the graph, okay, and it will give you a very brief, beautiful understanding of the word problems. So let me make you understand about some portions from my end, and then you can start with yours, okay?
Yes.
So I will first read out the graph for you. Let's read out the statement. So I want you to read it. Read it loud.
Bernie is practicing the 100-meter dash on the straight portion of his school's track. He sprints 100 meters from the starting line, turns around, and sprints 100 meters back. Which graph could show Bernie's distance from the starting line over time?
So they are asking the distance, okay? We don't look at the graph as well. They are asking distance with respect to the time, and that is from the starting point. So if he's, let us say he's running 100-meter dash and straight portion, he's running on a straight line, so the distance will increase, and after some times the distance will decrease. So either it will be a curve if it is not running in a uniform motion. Suppose he is taking a break, but 100-meter dash he won't be taking a break. Let us say he is running at a very fast speed, at an average speed. So the graph will be a straight line and then will come back like this. So you have to choose out of this. So I hope that you have easily understood that this is the right graph.
Yes.
Understood? Let us see this again. So it's my favorite sheet, you can see, because a student will get to understand the graph from the very, we say, the statements. So I want you to read the statement again.
Caden's science class is studying tadpoles. Each tadpole is born with a tail, which it keeps for a few weeks. Once the tadpole starts to become a froglet, its tail shrinks away to nothing. Which graph could show the length of the tadpole's tail in relation to its age?
So you see that when the age is increasing, the tail is decreasing because he has born already with a tail. So that means the graph will be something like this.
Yes.
Okay, let us see. So, okay, initially they are saying which keeps it for a few weeks. So for a week the tail is constant.
Yes.
For a few weeks the tail is constant. After that it is reducing and it reduced to 0. So this is the right graph. All right.
Yes.
So now you can start doing at your own.
Okay.
I will check how many questions you are able to do. And keep reading the question itself.
Should I read it out?
Yeah.
Okay, Mr. Harris preheats the oven so he can bake his famous cherry pie. Once the oven is warm enough, he puts the pie in to bake. Which graph could show the temperature in the oven over time?
Okay. Which graph could show the temperature of the oven over the time? They are talking about oven. So once the oven is warm enough, he puts the pie in the bake. So that means he is not continuously increasing. Are you getting it?
So it remains constant.
Mr. Harris, yeah, because only then I think the bake will be cooked. Okay, just check it out. Terrific.
Yes. Oh, it's the same one.
Same question. Okay, so the questions are same only.
Tracy is hiking Stoneview Mountain. The trailhead starts just above the base. Along the hike, she stops a few times to take pictures. The view from the peak is beautiful. The graph could show Tracy's elevation as she heads to the peak.
So I can see only one graph here. Okay, there are two graphs. Okay.
She
So
stops a few times to take pictures.
yeah, so if you see the second graph, you see that it is continuously being, you can say it is walking only, walking at a great speed, then walking at another speed. But here you see that she is being stopped for taking some pictures, so the time is elapsed.
Yes.
Okay, so distance is same, distance is same. So I think the first one should be the right answer.
No, it's this one.
Okay, because it was not relative time. I've also got confused because this is not time. Let's read. Tracy makes it to the top, so the graph should end at the highest elevation. Okay, what about this one? Okay, so this is showing that it is not going at the highest elevation. Okay, so we have to ensure we have to read the whole graph. You see, Tracy is hiking Stoneview Mountain. The trailhead starts just above the base. Tracy starts hiking little higher than the base of the mountain. So the graph should start at an elevation that is above 0 feet. Okay, so this is fine with this as well. Then just wait, don't get wrong, got it. The graph should be increasing.
Yes.
Her elevation increases as Tracy hikes farther from the trailhead. Her elevation increases, the graph should be increasing. Along the hike, she stops a few times to take pictures. Notice that when Tracy stops, her distance from the trailhead does not change. So there should be no horizontal segments. Okay, so I got confused because I thought that this is the time. But as soon as you were clicking on it, I got a doubt. I was about to say don't click. Okay, fine. So it's okay that we have got wrong.
Yes.
We have got to learn this. Next one. I think this is easy. This can be done by you.
Yeah.
Great going, Akriti.
Thank you, sir. Also, we did this question too, no?
What, beta?
I think we did this question too.
Yes.
There's the brain being very upset, crying, and all. Wait, I forgot the answer to this one.
Good one, Akriti.
Thank you, sir.
Sarah is excited for the first snow of the year. Throughout the day, she notices that the snow fell heavily at the first and then slowed for a while. Toward the end of the day, the snowfall increased briefly again and then tapered off. Which graph shows the total amount of snowfall over the course? So Sarah is excited for the first snow of the year. Throughout the day, she notices that snow fell heavily. So snow is falling heavily. That means the graph is same, and then slowed down for a while. So if it is slowing down, then it will not come down, it will remain constant. Toward the end of the day, the snowfall increased briefly and yet again it tapered off. So the second one is the right answer. Okay, do you know how many kind of curves are there in the total all of the mathematics and physics?
No.
So there's six basic types of curves. Let's understand that first. Okay, so there are 6 basic different types of graph, and it's a very great thing that you can understand from the graph itself. If you see the graph, so it may happen that anything in the life is a straight line, you can say. So when something is a straight line, means it is increasing proportionally. We say that it is increasing proportionally. So when something is increasing proportionally, I will give you an example as well. Let us say that this is a rectangle, and let us say that we have fixed the breadth, or we can fix the length as well. What do you want to fix? Tell me, what do you want to fix? Either fix the length or the breadth. Length. So I can change the breadth. Let us say this is the length, so I can change the breadth. So I can change it to 4, I can change it to 6, I can change it to 8, I can change the breadth. Are you getting it? So when I will change the breadth, what will happen? See, so let us say it is 8 into 2, which is 16. If I change it to 3, what will be the area? 24. If I change breadth to 4, what will be the area? It will be 32.
32.
Now if you see that 16 upon 2, 24 upon 3 and 32 upon 4 all are having the same value, which is 8. And this 8 is defined, you can say it is also known as a slope of the graph. It is the rate at which it is increasing. If you increase this by 1 unit, the area is going to increase by 8 units. Are you getting this?
Yes, sir.
So what does it say? That if I draw the graph of area versus breadth, it is going to be of straight line. So such graph are known as increasing with constant rate. This is the first kind of graph. Increasing with constant rate. Increasing in temperature, let us say if you are speed versus if you see distance versus time graph, distance versus speed graph, all these graphs, if somebody is moving at a uniform velocity, we say that all these graphs are straight lines. So this is known as increasing with the constant rate. This is first kind of graph. All right. It may happen that something which is also increasing can also decrease as well.
Yes.
So what do you think? If it is decreasing, what the name of the graph will be?
Decreasing proportionally.
Very good. So you will say decreasing with constant rate. So when the graph is a straight line, you will say either it will be increasing or it will be decreasing. So these are the first two kind of graph. Are you getting it?
Yes.
Then coming to the next two kind of graph. So in this, we will say the graph is, so let us suppose that this is the straight line through which we are going to draw the graph. This is a straight line. All right. Now what do you think if the graph is like this? Just it's starting below and then it keeps on going like this and it will cross this line somewhere in the life. Somewhere later it is going to cross
It's
this.
increasing but not in proportion.
No, but you will say what is the rate of change? So you will say increasing with, you say what is going to be the rate? The rate is not proportional, that is fine. But is the rate increasing over the period of time or it is decreasing over the period of time?
Increasing.
Increasing. So you will say increasing with increasing rate. Increasing with increasing rate. And where you can see such graph? Such graph are known as, you can say it can be seen in parabola. So it is parabolic. You see, you throw a ball, when it comes down, or there is a projectile motion, all those motions are covered into this parabolic path. Are you getting it?
Yes.
But if it is increasing with increasing rate, can't it be decreasing with the increasing rate? So the same graph can start from here again. You can see. So it will be compared with the decreasing function. So it will start from here and after a period of time you can see it is decreasing, but the rate of decrease is increasing. So you will say decreasing with what rate? Increasing rate. Decreasing with increasing rate. These are two more types of graph. So we say either it can be of the form x square, so it will be of the form minus x square. Decreasing. If this is of the form y is equal to mx plus c, this is going to be the form y is equal to minus mx plus c. Are you getting it? Just there is a change in sign. So two more graph. I want you to draw both the graphs. Just like a curve, you can draw it. Done?
Yes, sir.
Okay, now the last two graphs. So this is the third one and this is the fourth one. Then sometimes it may happen that initially somebody, so have you ever seen a person running 400-meter race? So if you see, I have seen many of the students who go for 400-meter race. Initially they will run very fast, but as soon as they reach to the midpoint, they are just like this. Have you seen those? So they don't know how to run actually. So they start very early, but after sometimes they are about to die. So these kind of graph are known as, they are increasing. They are always increasing, but increasing with decreasing rate. So if I give you an example, somebody is applying brakes. The distance is increasing, but the velocity is decreasing. Somebody is applying brakes. So increasing with decreasing the rate. And then there is a last graph. What you are going to say about this? Wonderful. Decreasing with decreasing rate. So what will happen? It will start very early, but after some time it will go like this. So we say that it is decreasing with decreasing rate. So this is the fifth graph and this is the sixth graph. So these are the graph of, you can say, square root of x. If I want to say the square root of x, the graph will be like this. And this can be like minus of root x. Let me see on GeoGebra as well. See this graph? Okay, it is decreasing. So it is increasing with decreasing rate. The rate is decreasing. And then if I draw the graph of negative root x, so it is going below this. So if I just add something to this, let us say if I add plus 10 units, or let us say plus 4, you can see this graph now. Are you getting it? So the graph is decreasing, but it is decreasing with a decreasing, the rate of decrease is also decreasing. All right. So whenever from hereafter you are watching the graph, you have to see the kind of graph. It will be among these 6 graphs only. So that is increasing with a constant rate, not increasing. The graph is dead. Increasing with a
Yeah.
constant rate, dead. Increasing with a constant rate. Here, increasing. Are you getting it now?
Yes.
So you finish your sheet
Mhm.
and let us finish mine. Okay, Agriti, rest of the questions you can do by yourself,
Yes.
and you can also watch the video if you want. Okay,
Yes.
so I hope that you have understood this.
Yes.
And after this also you can just go with suppose you get free time, you can go with A7 and A8. These are very two simple sheets. You just need to add the functions. Like suppose if you see here, uh, you have to write the function in the simplest form. So f of gx, so you need to add this. So when you add this one, you will get 3x square plus 2x. So this will become 3x square. You can use this to write square, and then plus 2x. All right, so this is just the addition and subtraction and multiplication. You can also watch the video and go through this. And then there is a sheet of eighth, which is also a function only, and it's a wonderful sheet. I think this is very important. Let me teach you a brief idea about the first question. So it is said as f of gx. So what we have to do is, suppose in fx, you see what is written here, x plus 5. So they are saying f of gx means it is like f of gx. So wherever there is x, you have to substitute by 3x, means gx. So instead of x, now what you will write? You will write 3x and then 5. So the answer will be 3x plus 5. All right.
Yes.
Let us do one more. So what will be for this? Tell me easily.
5x plus 3.
No, my dear. I thought
5 plus x plus 3?
no, it will not be 5x plus 3. Yeah, 5 of x plus 3 is fine.
Yeah.
So 5 of x plus 3 is how much? You will say you have to simplify this. 5x plus 15.
Then it will be 5x plus 15.
Wonderful. Understood? So you can try both these sheets, okay, and this you can done in your free time. And please do watch the video as well, because video will give you some of the glimpses which I am not able to give you. Probably, okay, in 5 minutes you will get to learn so many things. Chalo, bye, take care. Let's meet on then next Wednesday, okay? And when is your next exam going to happen?
We don't know. We didn't get an email.
So prepare yourself. Make use of this time, okay?
Yes.
Chalo, bye.
Okay. Bye.
Bye. तो अब आओ तुमसे बात करते हैं पहले. तो आरव, एक्चुअली जब पेड बैच चलता है हमारा, तो उस टाइम पे हम बहुत सारी बातें नहीं कर सकते. अभी तुम्हारा जो डाउट है उसको क्लियर करते हैं. वो तो क्वेश्चन चला गया बेटा, वो क्वेश्चन दोबारा नहीं दिखेगा. तो सबसे पहले अगर तुम्हें एक्सेल का प्रोग्राम चाहिए तो मुझे कांटेक्ट कर सकते हो 9560143504 पे. मुझे मैसेज करना, उस पर मैं टाइम निकाल के तुमको बताऊंगा, तुम्हें इस प्रोग्राम के बारे में बताऊंगा, फोन पे बता दूंगा, तुम खुद देख लेना, ठीक है. दूसरी बात, ये प्रोग्राम के अंदर ही आपको ये सारे सवाल करने को मिलेंगे. अब वो गलत कैसे हुआ तो फिर बेटा उसके नीचे एक्सप्लेनेशन दिया रहता है. फॉर एग्जाम्पल कोई भी क्वेश्चन ले लेते हैं, कहाँ गया, यही कर रहे थे हम लोग. तो अब ये पता नहीं मुझे, अभी इसमें तुम ये करवाना चाहोगे? हाय BMW ऑफिशियल, बताओ आपको क्या पता ना. कुछ देर पहले क्या लिख रहे थे मुझे समझ नहीं आया. अच्छा, अभी तो कंकरेंट व्यूअर्स 0 है. सो मुझे लग रहा है कि कोई है अभी. इज एनीबडी देयर? कोई ये क्वेश्चन करना चाहता है? क्योंकि मैंने तो ऑलरेडी कर रखे हैं, तो फिर मैं बोर हो गया हूं. अगर आपको खुद से प्रैक्टिस करना है, यू कैन जस्ट परचेज दिस फ्रॉम मी, एक्सेल का प्रोग्राम, ठीक है. और यू कैन ज्वाइन माई, मेरे ख्याल से जो हमारा पेड बैच है उसमें तुम लोगों की एंट्री मुझे देखनी पड़ेगी. आपका बोर्ड कैसा है, आप किस जगह पे हो, वो सब हम सिनेरियो देखेंगे, उसके बाद ही होगा. वरना यूट्यूब पे तो फ्री में देता ही हूँ क्लासेस. यू कैन ज्वाइन वेरी वेल फ्रॉम द यूट्यूब एज. चलो, किसी का कोई क्वेश्चन है क्या? सो आई एम गोइंग टू एंड दिस सेशन नाउ, बिकॉज मेरे पास एक और सेशन है, इसके बाद 3 बजे से मेरा एक और डेमो है. सो प्लीज टेक केयर, बाय.